Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture is titled Two Eclipses of Saros 133. So what do we see here? Well, here we see what look like two images of a lunar eclipse, and indeed they are. However, these are two different lunar eclipses, but they are related because they are part of the same Saros cycle. Now, the eclipses occurred back in February of 2008, and then again on March 3rd of this year. And the Saros cycle, which was discovered a long time ago, showed that there was a pattern of eclipses. And in fact, the same eclipse would occur every 18 years, 11 1/3 days. So here we can see that 18 years later and 11 days later, we see the same eclipse. Now, the third of a day comes in as it changes where on Earth that would be located, because the Earth would have made about 1/3 of a rotation in those 8 hours. So you'll note that the first one was visible in Turkey, and the second one was visible in the United States at Kitt Peak National Observatory out in Arizona. So very big difference in the place around the world, but the eclipse looks almost exactly the same, and that's because of this pattern that has been discovered. Now, another one will occur again, so we can calculate out when this would be, and that would actually occur on March 13th of 2044. We would have another lunar eclipse much like this one. Now, they aren't exactly perfect, and if you look, you can see some slight differences between the two, but they will be very close. We notice this with the solar eclipses. Yes, they follow the same Saros cycle, but they're not in exactly the same location. The eclipse paths may change a little bit. These are the overall positioning of the sun, moon, and earth. However, there is a lot of fine detail in there that can cause slight variations, but it still is useful for being able to predict when an eclipse will occur. And of course, more detailed calculations can tell you exactly when and where that would occur. Now here, when we see the eclipse, we watch the moon passing into Earth's shadow. And the deeper it is into Earth's shadow, the deeper red it is. So in both of these images, Earth's shadow is to the upper left-hand side. And we can see that because the upper left portion of the moon in both images is a very deep red. It is well within Earth's shadow, whereas the other side of it is very light in color, barely covered at all in the Earth's shadow. So as you get further and further into the Earth's shadow, it gets darker and darker and a deeper and deeper red. And that's because of Earth's atmosphere. The atmosphere scatters light from the sun into the atmosphere and is very good at scattering the long wavelength red lights. So those deep reds are the ones that end up in the Earth's shadow and end up illuminating the moon, giving us the blood moon that we see during a total lunar eclipse. So that was our picture of the day, titled Two Eclipses of Saros 133. We'll be back again tomorrow for the next picture, previewed to be Aurora Arbor Borealis. So we'll see what that is about tomorrow. And until then, have a great day, everyone, and I will see you in class.